channel. So today we will discuss Leetcode Daily Problem part sum. So in this question, what the question is asking is, we are given a binary tree, right? We are given a binary tree, and in that binary tree, we have to find the path from root to the leaf node. So we have to find the path from the root to the leaf node whose node values will sum up to the target sum. So for example, in this binary tree, we have the binary tree. Now we have to find the paths whose node values will sum up to 22. So in this tree, we can say that 5, 4, 11, 2. Okay, 5, 4, 11, 2. They sum up to 22. Then 5, 8, 4, 5. They sum up to 22. So in the answer, we will have this 2D vector which will have the arrays which is nothing but the path from root to the leaf node. Okay, so you might now be guessing that what can be the approach, how can we solve this question. So given a binary tree, now hearing this name binary tree, we can say that we have to iterate to its nodes, right? And to iterate a tree, we have two things. Either we can do DFS or we can do BFS. So in DFS, we go through the depths, and in BFS, we go through the breadths, right? And now, in the question, it is rightly saying that we have to find a path from the root to the leaf node. So it's pretty much clear that we have to use DFS. Okay. So our first thing is clear, we will use DFS. Now, to solve any DFS question, like we generally use recursion. Okay. So for recursion, what is the first thing we need? We need a base case. Right. So what can be a base case in this binary tree? A base case can be if this node is null. So we can't perform any operation on a null node. So we'll just, a base case will be nothing but if the root is null, we will simply return. Okay, we'll perform no operation. Now, what's next thing? Also, in DFS, first we will go through the left child, then we will go through the right child. So first thing is a base case if root equals to null, then we will return. And secondly, if we have root left, then we will go to the left child. So let's say our function is solve. Okay, and we will go to root left, and then after traversing the left side, we will go to the right side. If root right exists, we'll solve the root right. Now what is left? So our solve function, whatever it is, solve function is pretty much, structure is done. What we have to do? We just have to fill in the blanks, right? Now, let's come back to our question. Let's dive deep into what the question is asking. So, I'll just erase this part for now. Okay, so let's take a deep dive into our problem statement. So, our problem statement is saying that from traversing from 5 to 4 to 11 to 7, we have to keep count of whether this sum from root to leaf node, whether we are getting the sum 22, whatever our target sum is, whether we are getting the target sum or not. So let's say for 5, let's say we don't have this tree, we just have 5. So is a So first thing we can say is, if we have only 5, then we'll check, is it a child node? So it is a root node as well as child node, because it is a root node. So we will check, is it a leaf node? So we will so 5 is basically right now, it is a root node also and it is a child node also. Next, what we have, to the left of 4, to the left of 5 we have 4, and to the right we have, or let's say we'll just perform both, whatever is a DFS. Okay, so what we have, so to the left of 5 we have 4. Now to the left of 11, to the left of 4 we have 11, and to the left of 11 we will have 7. Our DFS will work the same way, like the DFS will go from here, then here, then here, and then it will go back to 11, and then to 2, from 2 it will go back to 11, then to 5, then to 8, 13, 8, 4, 5, 4, 1, then again back to 4, again back to 8, again back to 5, and then we will return whatever is our answer. Now, what I can say is, if at point 5 is 5 a leaf node? So no, it's not a leaf node. Okay, we will go to its child. Now we will check, is 4 a leaf node? No, 4 is not a leaf node. We'll go to its child. Is 11 a leaf node? No, it's not a leaf node. Is 7 a leaf node? Yes, 7 is a leaf node. So 7 is a leaf node. Now what we need? Next we need that, is the sum of all these nodes equal to 22? So what for 7, what can I have is, if I somehow manage to get whatever my previous sum is, whatever the previous sum, so the previous sum will be 5 plus 4 plus 11, it will be 20. Now for 7, if I somehow manage to get the previous sum 20, and then I'll add this roots value, I'll add this nodes value, so 20 plus 7 will get 27. So is it equals to a target sum? No, it's not equal. So we will simply return back to 11. Okay. Now, at 11 we have a right child. So the right child is 22. Okay. Now also for 2, what will be the previous sum? Previous sum will be 20. Like sum of 5, 4, 11, 20. And also previous sum plus this nodes value 2, it's equals to 20. Right? Now 22 is equal to our target sum. So what I can do is, I will have to add this 2 to some array or to some vector or list that will have all the previous nodes as well. So apart from previous, I can also have a temporary array. Let's say temporary array. Okay. And then this temporary array I will push back to. Is this clear? So for each node we will maintain a previous, whatever the previous sum of its ancestors are there, and also for every node we will have a temporary array, and we will push back whatever the node's value is there in that temporary array. Now we need this temporary array, so at 2 the temporary array will become 5, 4, 11, 2. Now this temporary array is part of a answer array. So let's say the answer array, okay, is answer array, and in this answer array we will do nothing but we will push the temporary array. So we will push back the temporary array. I think this solution is pretty much clear. So let's go on for the code. Okay, so this is a code, whatever code is written. So having this is a pre-written a function that was given in the Leetcode. So what I'm doing is, this is our answer to the array, and then this is a temporary answer that I told you about. This is a previous, and then we'll pass all these variables in the solve function. Now in the solve function, what I'm doing is, okay, the base case, that is the root equals to null, then I'll return it simply. And then also, okay, so if a node is the leaf node, so we'll just check if root left equals to null and root right equals to null, and also root's value plus the previous value equals to temporary string. Then in the temporary answer, we'll push back the root's value, whatever the root's value is there, and that temporary answer we can push back in the answer. Also we have this temporary answer dot pop back. Why is it so? So that is because 2, if I have inserted 2 in the temporary answer, then what will happen in the DFS traversal, 2 will go to 11, and now at 11 we don't have any 2, because when we are coming back from 2 to 11, we won't consider 7 and 2, we'll just consider 5, 4, 11, and then from 11 we'll go back to 4. Okay, so like I'll just explain you the code. So what happens that if we have the root node, leaf node, and the root value plus the previous sum equals to temporary sum, then we'll push back a temporary answer in the answer. Else what we are going to do is, in the previous we will update the previous every time with the root's value. Okay, then in the temporary answer we'll push back the root value, and this is just for debugging. Now what this is a DFS code, like if root left exists, then we'll solve for left part, else then we'll solve for the right part. And once I come back from the right child, what I'll do, I'll decrement the previous from the I'll decrement the root value from the previous, and also I'll pop back, I'll remove that element from the temporary answer. And so I'll just run this code. Yes, so it's the sample test case is accepted. Also our solution is also accepted. That's it. Thank you.